This is a single slit diffraction equation problem, and we have a single slit, first minimum at 14.5 degrees. You've seen this one before. At what angle is the second order minimum? So to solve this one, we begin with the fact that we have d sine theta equals m lambda, and the first order minimum is m equals 1, and that's 14.5 degrees. And so we know that sine of 14.5 degrees, oh, pardon me, sine of 14.5 degrees equals lambda over d, right? So we now know what lambda over d is, and so we can put in here, right, what is the second order minimum. So sine of the second order minimum, right, is 2 times lambda over d, is 2 times sine of 14.5 degrees. So what is 2 times the sine of 14.5 degrees? Well, first let's get the sine of the radians. 14.5 degrees is 0.25038, and so 2 times that is the sine of the theta 2, right? 0.5076 equals 0.5076, all right? And that means theta 2 is the inverse sine of 0.5076, and that is a sine of that, and degrees, that, so 0.524 degrees or 30.1, 0.524 radians or 30.1 degrees. 0.524 radians equals 30.1 degrees. So that's the answer to part A, right? Part B, what is the angle of the third order minimum? So for the third order minimum, we of course just have sine of theta 3 equals 3 times lambda over d, right? Equals 3 times the sine of 14.5 degrees equals, okay. If you remember right here, we have the sine of 14.5 degrees, so 3 times that is 0.75114, right? 0.7511, we'll just take it to 11. And that means that the third minima is at the inverse sine of 0.7511, and this equals, okay, so the inverse sine is 0.489 our 0.850 radians are 48.7 degrees. 0.48 radians are, what was the number in degrees? Oh, I got that wrong. 85 radians. 85 radians, or in degrees, 48.7 degrees. So that's the third order minimum, right? What is there a fourth order minimum? So if we start talking fourth order minimum, right, we have sine of theta 4 equals 4 lambda over d equals 4 times the sine of 14.5 degrees. All right, 4 times the sine of 14.5 degrees, and so 4 times that is 1.002. Right? So this yields, there is no fourth order minima, right? Because the sine cannot be greater than 1. Sine cannot be greater than 1. So there is no fourth order minimum. And use your Allensters in part D. Use your answer to illustrate how the angular width, the central maximum is about twice the angular width of the next maximum. So angular width of central maxima equals 2 times 14.5 degrees equals 19 degrees. All right, that's the width of the central maxima. Next maxima equals 30.1 degrees. Next maxima width equals 30.1 degrees minus 14.5 degrees equals, let's see, that's 15.6 degrees. So, oh, that's silly. Twice 14.5 is 29 degrees. All right? So 29 degrees, roughly twice that of the next width, 15.6 degrees. And that's it for problem 1.